Hey everybody, Chris McClure here. So we're going to start our discussion of new material for this Math 157 statistics course. All right, so we're going to go ahead and start with the very first section of the first chapter and talk about just general ideas and some specific terms and their definitions. And of course, as we go through the semester, we'll explore these things in more detail. But what I want to talk about, though, is, what is statistics? What do we do? What are the different methodologies that we can use? What are the various tests? How can we do analysis and so forth? So here's kind of a preview of what we're looking at, and I'll let you read that. But basically, what we're saying is that we're going to be talking about taking polls, surveys, some other means of gaining data. And this data could be in the form of a sample. And we're going to use the word sample a lot through the semester. And what a sample is nothing more than just a subset of a larger group, which we call the population. It may very well be that we don't have enough resources to make measurements of every individual in the population. Think about it. In the United States, we have well over 300 million people. So it's practically impossible for us to get everyone's opinion regarding, say, who they prefer for president. But if we could take a sample, meaning we take a measurement, as in ask a question, for example, of a pretty good subset, and we'll talk about what that means, by the way, of the population, we can extend the results from that sample to the overall population with a certain amount of confidence. And we're going to, again, take a look at what exactly is a sample and what is the population, because they have very specific meanings in the context of this course. And we're going to also take a look at how to describe data. You go out and you take your sample, and what we mean by taking a sample is we go out there and take a measurement, at least one measurement, could be two or three, or multiple measurements of different types of each individual in the sample. And then what do we do with all those numbers or other types of data? So that's what we're going to be looking at. So what is data? Well, here's the definition of data. Collection of observations, responses to surveys maybe, or length of a fish, for all the fish that you catch, or the weight of the fish, or maybe a color or size of t-shirts. Now, here is the definition, or at least a definition, of statistics, as in the field of statistics. I'll let you read that. In other words, what we're doing is we're turning data into information as a way of trying to answer some sort of question. It kind of follows the methodology of the scientific method. Now, the population under question is the complete collection of all measurements or data that are being considered. So, for example, at Saylorville Lake, right outside of Ankeny here in Iowa, there very well could be millions and millions of striped bass fish, for example, or catfish, or name your species. We have no way of knowing, the lengths of all of those fish. But what we could do, though, is we could take a sample of the fish, which is nothing more than a subset of that population. And each fish that we catch, we can measure the length of it and throw the fish back in. Again, there's no practical way for us to measure every fish in the lake. In order for us to do that, though, we would have to drain the lake and spend a lot of time going through one fish at a time and measuring, in which case we would be doing a census. Census is where we measure every individual in the population. Very rarely done. You might remember the word census is what we try to do here in the United States every 10 years as mandated by the Constitution, that we will go through and count every individual here in the United States and get information about them. It's a big project. And the larger the population is, the bigger the project is. But you know what? If we can get a good sample, meaning a good subset, a representative subset of the population, and not just a small one, but a relatively large sample, as large as our resources allow. I'm talking about resources like time and money. So as large of a sample as we can reasonably get, then the results that we get from analyzing the sample should be representative of the population as a whole. So here's a bit of an example here. The Gallup Corporation, they're famous for the polls and surveys that they do. And suppose that in this example that the Gallup Corporation collected data from 1,013 adults in the United States. And suppose, though, that 66% of those adults surveyed, they worried about identity theft. So in this study, to answer the question, what is the population under consideration? Well, the population consists of all the adults in the United States. Now, this isn't the whole population, but this is an estimate of the number of adults in the United States. And to tighten that up, the population is actually the set of responses to this question regarding identity theft for all the adults in the United States. The sample is just the 1,013 adults polled. The sample is just that subset of the population. What is the objective of this survey, of this study? What is the objective? It's to use the sample data as a basis for drawing a conclusion about the whole population. So if we're curious as to what proportion of the population is concerned about identity theft, well, if this 1,013 adults was representative of the population as a whole, then we should conclude that approximately 2/3 of the population of United States adults is concerned about identity theft. Somewhere in the neighborhood of 2/3. Now, we'll talk about exactly what that means. We'll talk about a confidence interval, for example. But we can extend the results of the survey to the whole population if that sample was any good. All right. Now, that was section 1.1. We're going to move along to section 1.2. You'll find that as I record these videos, I'll oftentimes get 2, sometimes even 3 sections all in one recording. Okay. All right, so section 1.2, statistical and critical thinking. So here are some steps that we use in doing a statistical study, and these are not always one at a time steps and only done once. Sometimes we have to go around in a circle and do these multiple times. Sometimes these steps overlap each other as well. But just understand, though, that these are general, discrete steps, though, for any sort of scientific study, including statistical studies. So, in preparing to do a statistical study, we try to think about what is it that we really want to do? What do we want to measure? What is the goal of the study? Okay. And who's going to do the collection of the data? Who's paying for it? Who's actually conducting the survey, for example? Where is it being done at? These top 2 bullets right here kind of go back to, should you trust the results of a study done by a company who has some skin in the game? Meaning, do the results favor the organization or individual who's done the sample? So, for example, would you trust the results of a study regarding the link between smoking and cancer if that statistical study or scientific study was done by the same corporation that owns tobacco, meaning they own a cigarette making company? There might be some validity to it, but I wouldn't trust it because, it wouldn't look good for that company to produce the results of a study that actually showed that there is definitely a link between tobacco consumption and increased rates of cancer. So if you are preparing to do a statistical study, think about it from the perspective of some outsider. Would they perceive you as being biased? So you have to decide that. Or if you yourself are reading the results of somebody else's study, do you think there's a conflict of interest? So be careful about that. Well, there's different ways of doing a study. You could do an experiment. You can do an observational study. And the method that you use could very well influence the outcome. So think about, for example, the link between smoking and lung cancer. You could do an observational study, or you could do experimental sort of study, and we'll talk about what exactly those are. Or you could talk about, doing a study regarding people's views toward, say, gay marriage or gambling. Maybe you're wanting to know if there's a feeling of tolerance in the community toward a new casino nearby. So how would you go about? Would you, hand out survey forms outside of all the churches in the community, for example? Or would you go around tapping people on the shoulder at the American Legion Hall? Or would you put up a poll on the website of your organization? And the problem with all of those things is that, like in any survey, is that not everyone is going to choose to respond to your question, or they may misrepresent their feelings. So, but we'll look at some ways, though, of at least tightening that up and getting better results so that we don't have this problem regarding voluntary response bias, involuntary participation bias. Okay? Because, if you do not carefully plan your study, then your results will be questionable. We'll talk about how after you get your data and you go about starting to do your analysis, that you begin with sorting your data, organizing it, and doing some sort of graph, like a histogram or a line chart. We'll talk about those in the next chapter. We'll talk about some different statistical methods that you can use to make a conclusion about the population as a whole. We'll look at some different types of technology. I'll show you how to do some analysis on your graphing calculator. And I certainly hope everyone gets a graphing calculator of some kind. I would recommend a TI-84 Plus. I'll also show you how to use StatCrunch, which is an off-the-shelf sort of free software that comes with MyStatLab. But there are many other sort of statistical platforms and statistical analysis platforms that are easy to use. Some are more sophisticated and require some more training to do. But regardless of what technology that you use, the reason that you're taking this class is so you could develop some common sense and some basic statistical understanding, so you could have some decent results. We're going to talk about this very important concept of statistical significance. And I'm going to give you a real quick example of statistical significance. Now, suppose that someone hands you a coin, could be a quarter or a nickel or whatever, and that they want to play a coin flipping game, and which for every head that turns up, that they get $1, that you have to pay them $1, but every tail that comes up, they pay you $1. Now, you don't know this person, you don't know anything about this coin. Would you want to play? And I tell you what, I would be very skeptical. So what I would do is I would do some sort of experiment to help me decide whether or not the coin is a fair coin. And a fair coin means that each side is equally likely to come up. So how can I decide whether it's a fair coin or not? Well, what I could do is I could flip that coin a whole bunch of times. And each time I flip the coin, I will mark down whether it's a head or a tail. So as I go through and flip the coin a bunch of times, I'll record the number of heads and the number of tails. Now, let's just suppose that I flip the coin, I don't know, 1,000 times. Now, we would expect, if it was a fair coin, that the number of heads should be somewhere not too far from 500. So 500, yeah, right on the money. We wouldn't expect for it to be exactly 500 though. But, somewhere between, I don't know, 400 and 600 would be very likely. The further that you go away from 500 heads though, the less likely you are. Now, suppose though that only 75 out of the 1,000 coin flips resulted in heads. Is that 75 such a departure from the expected 500 that is unlikely to have happened by chance alone? And the answer is yes. Now, we very well could have a fair coin, and it's entirely possible to have only 75 heads, but it's not very likely. We would call a result statistically significant. Because if we had a fair coin, it's very unlikely to have gotten a result as extreme as what we did, just by chance alone. Now, I'm going to bring that sort of thing up many times throughout this semester as, as a matter of significance. When you get a result that's unlikely to have happened by chance alone, we say that you have a significant result. And we'll talk about how we would reject the null hypothesis, which is like the going sort of assumption. For example, if you have a person on trial for murder, and we look at all the evidence that's laid out against this man, then any sort of mitigating circumstances presented by the defense, we have to, if we are a juror, take a look at, maybe this person was caught with the murder weapon in his hand at the, place of the murder. Maybe he knew this individual. Maybe this person was angry at this other person. Maybe there was just some sequence of circumstances in which this defendant would have every reason in the world to commit this murder. But it could be, though, that he didn't commit the murder. He just happened to be at the wrong place at the wrong time, in the wrong circumstances, even though he is actually innocent. But because of the weight of the evidence is such that he is found to be guilty, it's unlikely that he's innocent, though, because we really don't know for sure. We have to go with the evidence that we have, though. It could very well be that we have a sample that just by a fluke was just very different from what a more normal sample would be, whatever that means. It could be that if I had 10 fair coins and I were to flip all 10 coins, that they're all heads. If I had 10 dice, all of them are fair, and I roll all 10 dice, it could be that I get 10 sixes. All of them are sixes, which is possible but unlikely. All of those would be statistically significant results, unlikely to have happened by chance alone. Now, when we report the results of our study, we have to report, based on the sample and based on the analysis. But we also have to take a step back and decide whether, there is a, common sense sort of practical um, significance to the results. And as an example here, suppose though that we have been studying a certain weight loss program, with 40 subjects after 1 year, and suppose that we have an average weight loss of 4.6 pounds. Now, is that significant? Yes, it is. And we can conclude that there's a significant loss of weight, but is it practical though? But honestly, I think the average person could do, practically nothing except maybe, drink one less beer per day, or, walk, a little bit extra, every day, and making very small changes in his or her diet and exercise, and still lose 4.6 pounds without meaning to. So, in the big scheme of things, I don't think that this study produced a practically significant result. It's a judgment call, though. Now, if it was 20 pounds over a year, that would be practically significant. But this result here, not so much. Okay? So, we have to, again, be very careful. And, statistics is a little bit slippery. And I don't expect everyone to be statistical wizards. There are entire PhD programs in statistics. Now, I don't claim to have a PhD in statistics, but I've taken a number of graduate courses. And I tell you what, some of the stuff that we're going to go through, I didn't really fully understand until after a couple of graduate courses. So I'm going to try to explain it the best I can. But something to keep in mind is that when we're trying to, make a connection between two different phenomena, height versus weight, for example, or a diet of an expectant mother and the IQ of her children, or smoking versus pulse rate. Think about any two variables and just try to decide whether there's a connection between those two. And we'll talk about how we can, decide whether there is that connection. We'll take a look at correlation. And it could very well be, though, that two variables are correlated, meaning if you increase one variable, that results, or at least corresponds, to an increase in the other variable. So, for example, height versus weight of individuals, of people. Generally speaking, the taller somebody is, the heavier they're going to be. The shorter that they are, the less heavy that they are, right? So they are connected, but does one cause the other, or is it that it's just coincidental? Could it be that, it just so happens that people who smoke more have a higher pulse rate, or have a higher rate of cancer compared to people who smoke less, who have lower pulse rates and lower rates of cancer? Maybe, there's no connection. It just happens that it's coincidental. That's one explanation. Maybe there is a confounding variable that's linked to both of them. Like height versus weight. Height doesn't drive weight, weight doesn't drive height, but, it has to do with a person's body mass, which is influenced by things like diet and genetics and things like that. But we have to be very careful that in saying that one variable causes the other. Same, for example, regarding the connection between smoking and cancer, we'll have to go through and do a lot of steps in order to make that connection that says that increased smoking results in a higher rate of cancer. And not just, a connection, not just a correlation, but also we would have to be very careful in making the case that smoking causes cancer. That's just not something that we observe and casually declare because of the implications society-wide. If it turns out down in your neighborhood that there are 3 or 4 individuals who come down with leukemia all within a short amount of time, and there hasn't been leukemia at any time in the past, but oh, by the way, what's changed? Maybe high power lines got put up, behind your neighborhood. So it's easy to make that connection between the high power lines and the leukemia that's happening, but you couldn't win a lawsuit that way. But we'll talk about some statistical methods in order to strengthen your case in trying to link two different phenomena. Not just link them, but to establish causality. We also have to be careful that we have an adequate sample in order to have some confidence in our results. And of course, the larger the sample, the better, but simply taking, say, 3 students, for example, to establish the suspension rate for the school, that's not enough data points. Trying to make that connection between smoking and cancer shouldn't be done just with, 10 or 50, cancer patients or smokers. It should be done with tens or hundreds of thousands of people who are smokers or non-smokers in your statistical study. The more the better. So if you've got a city of size 1 million for the population and you only take a sample of size 10 and you sample these people from the bingo hall at the VFW and asking them about their views regarding gambling, well, you can't take the results of that survey and extend that to the population of the city. Be careful about that. Be careful about how you ask your questions. Here, in this example, 2 different ways of asking the same sort of question. How you ask your question could very well determine the response, not the response rate, but the yes rate, or the proportion of individuals who respond yes. So as you compare these 2 questions, you might think that they're asking the same thing. Well, they have at their core the question as to whether the President of the United States should have the line item veto. The second question is more direct. It needs to be neutral. It cannot be leading like this first one is. This first one is leading because it's kind of a foregone conclusion. Yeah, everybody wants to cut waste. So if that's the only way to cut waste, then yeah, absolutely, I'm all for it. Unless the critical thinkers are there, like, wait, there are other ways of cutting waste than just the line item veto. Because, by the way, the line item veto is a great way for a president to cherry pick a bill that comes before him. A bill that gets passed by both houses of Congress, result of a lot of compromise. There's a lot of give and take that goes into crafting a bipartisan bill, only for it to land at the president's desk, and then he or she can then go through it and pick out the things that he or she doesn't like. So there are certain downfalls of having a line item veto. But if you're only curious as to whether someone wants or supports the president having a line item veto, then keep it as general as possible right here, not a leading question like you see up here. Okay? Keep it neutral. And also, when you're asking, someone to choose between two or more choices, understand that you got to mix these things up, mix up the order. So, for example, if you want to ask this question regarding traffic and industry for air pollution, I would say half the questions have traffic go first and industry second, and the other half of the questions have industry go first, followed by traffic. Because generally speaking, a lot of people, if they don't have a strong opinion one way or the other, they'll just go with the first choice. Okay? So, and again, going back to response rate, something that you're going to have to deal with is whether somebody chooses to not respond, or they respond with a dishonest answer. Okay? Or if they start a study and then they drop out for some reason. Be careful about how you report your numbers. And it's impressive if you can report, say, a proportion out to, say, 6 decimal places. Hey, that's a very precise number, but is it meaningful? And the answer is no. So, just because you report 66.23475% of your sample reported yes, that they support Smith for governor, doesn't necessarily mean that it's an accurate number. It's a very precise number. So I just would report it as 66%. And also be careful about how you report your results. Look at this example right here. What exactly does it mean when this company says that we've already improved 100% in the last 6 months regarding lost baggage? What does that mean? Well, to me, I guess if I had to figure out what that meant, I would think, well, okay, one way that this could be true is, if they had a certain number of lost bags and they cut that in half or something. I don't know. This is meaningless to me. It means that they're 100% good. Do they have a substantial reduction? But what does it mean, a 100% improvement? So be careful about how you word your conclusion. So I know that this is all generic stuff, and that's okay. I just want you to start thinking about, what is a statistical study? What is a population? What is the sample? You know, what what are the different ways that we can go about doing our study, and so forth. So go ahead and read sections 1.1 and 1.2 of your textbook. And I think that you've got some homework posted for section 1.2. Okay, and then tomorrow we'll take a look at section 1.3. Okay, so with that, let me just remind you that you need to get your proctor forms filled out. And if you, I know some people have asked me regarding proctor form. Do you really need a proctor form? Well, the answer is yes. If you are going to take your midterm and final exam not at a DMAT campus. Now, if you live within about 50 miles of any DMAT campus, then I am going to expect for you to take your test at that DMAT campus. Whether it's Carroll or Newton or Boone. I think they even have one near Ames or Ankeny, West, Urban, wherever. Southridge, I think, on the south side of Des Moines. But if you live beyond 50-mile radius of any DMAT campus, then you need to look at your local high school or a local college, maybe even a military recruiter's office or library, and approach them, ask them if they would be willing to proctor an exam for you. And if so, then have them, or print out that proctor form that I emailed out. You fill out your part at the top, and then have them fill out their piece in the middle, and have them scan and email it to me, or fax it, or pop it in the snail mail to me. We need to get that sorted out as soon as possible. I don't want to have to jump through a bunch of hoops at the last minute before we take our midterm exam a month from now. Okay? So with that, I will see you next time. Take care.